So we've got cos of x equals 1 minus 3 cos squared x. In this equation, I hope that you can see that you have a quadratic equation. You have something squared, which we can sometimes get rid of by square rooting, but you won't be able to get rid of it if you also have another cos. How do you solve quadratic equations? You make one side equal to 0. So the first thing I'm going to do is I'm going to move everything over to the left side. 3 cos squared x plus cos x plus 1 equals 0. And now you have two options. Either you have to be able to factor that, or you have to use the quadratic formula. If factoring is not working for you, and sometimes they give you ones that cannot be factored, then you can always use the quadratic formula. Minus 1. Thank you. Good. Yes. That's that. This is an example of one that cannot be factored. So you would go to your formula sheet, and on your formula sheet it says, for ax squared plus bx plus c equals 0, x is equal to negative b plus or minus b squared over 2a. And we make a note that this formula has an x squared and an x, and our equation had a cos squared. So when we go to write it into the formula, instead of writing x equals, we will write cos x equals negative 1 plus or minus b squared is 1 minus 3 times a times c divided by 2a and we can split it up once with the plus. So the plus, we get negative 1 plus, simplifying inside, square root of 10 divided by 6, and once with the minus. And so we could get a decimal of this with our calculator. Try typing this into your calculator as well while I'm typing it in, just to make sure that your calculator skills are still up to it. 0.36.
Huh. Since the b part is already negative, you're adding in a negative 1, so wouldn't that just be 1?
The b value is a positive 1.
Oh, I
Yes.
was looking at the c value.
Yeah, and the c value here would be the negative 1. I'm having one of those days that I'm making mental math errors like crazy, so I wouldn't be surprised if I...
That 3 would be 4, like negative 3.
The negative 3. It's a 4. And I wrote a 3. That's not, I don't know, that's not even a mental math error, that's just a copy error. Thank you. So that will be a 4, just because I copied it directly from the formula wrong. And then that makes these 13s. See, it is one of those days that I'm making. And we have to change these decimals as a result. Go back to my calculator. The plus 1, I got 0.434. And subtract 1, I got negative 0.767. Okay. Now, this one on the left is positive. That's telling us from our CAS rule we're going to be looking in quadrant 1 and quadrant 4. We will find our reference angle by doing cos inverse of 0.434. And is this question in radians or degrees? In radians, so I now have to change my calculator back to radians. And I get 1.12 as my reference angle. I made another tiny little mistake. It's actually a half mark mistake second time. This one's even harder to notice. You know, I have cos x, and then I changed it to theta. That's another half mark mistake. That. These should just be x's, because our question was at x's. Can't change the variable. If you do change the variable and you don't have an eraser, if you wrote let x equal theta, then you're fine. But you have to write that somewhere. If you don't write that on the provincial exam, they would always take off a half mark if you changed your variable. So then my reference angle is not theta reference angle, it's x reference angle. And because it's in quadrant 1, I could write the same as my reference angle. And in quadrant 4, I would have to go 2 pi minus my reference angle and get 5.16. Same thing on the other side. I see that cos is negative, so I'm going to look in quadrant 2 and quadrant 3. I'd find my reference angle by doing cos inverse of positive 0.767, and I get a reference angle of 0.696. Then in quadrant 2, I would do pi minus my reference angle. And in quadrant 3, pi plus my reference angle. And I'm going to put a note that under here, both of these sets of answers are positive ones between 0 and 2 pi. This one was quadrant 1, this one was quadrant 4, this one was quadrant 2, this answer was quadrant 3. And now is when we read the question again and hope that they said solve between 0 and 2 pi, because then you're done. If we read it again and they say something else, we have to do some work yet. I have not a good feeling about this. What does it say? Ugh. From negative pi to pi. So what does that mean? This question wanted us to solve 0 to pi and 0 to negative pi. So, which answers do I have to not include? Quadrant 3 and quadrant 4 answers have to be negative. So temporarily, I'm just going to put a little line through that one, a little line through this one. My final answer should be x equals 1.12 was fine. 2.44 was fine. But I need to find out what this one would be if it was a negative answer. And since my reference angle was 1.12, in quadrant 4 it would be negative 1.12. And I need to find out what the answer in quadrant 3 was. And if this is the answer, if the answer in quadrant 2 was 2.44, does it make sense that the answer in negative in quadrant 3 would be the same number as the one in quadrant 2? So we would have negative 2.44. Part B, though, says determine the general solution. And for the general solution, I would, we have 4 answers between 0 and 2 pi. I would use the 1.12, the 5.16, the 2.44, and the 3.84 that we found. You add 2k pi to each of them. We can define k to be an integer to solve completely. Oh, and I read the question one more time, and it says to the nearest hundredth, and at least I randomly chose to round correctly. Because that would be like the adding, you know, you read your question again, only to find out you have to do more work, you have to do more work. At least this time we did round correctly, right from the beginning. So, sometimes you have to use the quadratic formula, sometimes you can factor. So in the questions for practice on these ones, 12, 13, and 14, some of them you'll be able to factor.